Okay, let's do something a little bit more interesting with Phoenix this time. What we're going to do is use the movie lens dataset again in the users table in particular, and we're going to write a pig script that uses Phoenix to actually write and store our users data table or relation in pig parlance into HBase via Phoenix, and then read it back and do some queries on it, again going through the Phoenix layer to hopefully optimize that interface between pig and HBase. So let's get started. First of all, we need to create the actual table that we're going to be working with before we can write a pig script against it. So let's see, where are we here? All right, you should still be in this directory, user HTTP current phoenix-client/bin, and we're going to go back into the command line interface by typing python SQL line.py. And there's our Phoenix prompt. So what we're going to do is create our users table that matches the same schema that is in the actual Movie Lens data file format. So we're going to say create table users, open parenthesis. First field is user ID, and that's going to be an integer value, and it is required, so we're going to say not null, comma. The second column is age, which is also an integer. There is then a gender field, which is going to be a single character, which we specify like that, character 1. There is an occupation field, which is also a varchar, a varying length character array. And there is a zip code, which is also a varchar, because different countries have different formats of zip codes. They're not necessarily just 5-digit numbers like they are in the US. So think globally, guys. Don't have a US-centric sense of postal code, all right? Now, again, we do need to have a primary key on any HBase table. It needs to know how to actually distribute this data, so we're going to say constraint pk primary key, and the primary key is going to be user ID. Close our parentheses, semicolon to end it off, and we should have our users table in HBase. Let's do a bang tables just to make sure it's in there. Sure enough, users, our new table. Woohoo! All right, let's get out of here. All right, so let's go back to our home directory for our friend MariaDev, /home/Maria_dev. All right, so we need to get a few things here. You might already have the ML-100K dataset installed in here. So if you do already have an ML-100K directory that contains a u.user file, then you can skip this next step. But otherwise, you will need to create one. So let's say mkdir make directory ML-100K. And let's cd into that directory we just created and retrieve the u.user file from my web server. wget http://media.sundog-soft.com/hadoop/ml-100k/u.user. Alrighty, so we have the data that we need for this exercise. Let's cd back up to our home directory. Again, we should be in the home MariaDev directory here. And let's get the pig script that I've prepared for this exercise. So wget http://media.sundog. Why can't I type that? -soft.com/hadoop/phoenix.pig. All right, so let's take a look at what's in phoenix.pig. Let's phoenix.pig. All right. So the first thing we need to do if we're going to be using Phoenix with a pig script is call this register command to tell it where to get the client libraries for Phoenix. So this is just saying go to the user HTTP current Phoenix client phoenixclient.jar archive and use that so that it knows where to find the Java classes it needs to connect pig to Phoenix, which will in turn connect you to HBase. Okay. So first thing we're going to do is load up the raw data from the pipe delimited text file that came from the ML-100K dataset, and we're going to transform it into a relation in pig called users. So all we're doing here is saying we're loading up this text file, u.user, that we just downloaded, using pig storage with a delimiter of pipe, and we're going to interpret each row as an integer user ID, an integer age, a character array gender, a character array occupation, and a character array zip. All right, now you need to make sure that these data types match the actual column data types that we defined in HBase as well as you can. You can't actually specify in as much specificity as we could in SQL, how many characters exactly are in a gender, but to some extent, the Phoenix Pig client connector can figure it out. All right, so now that we have that, let's actually store it into HBase. So this is saying we're going to store the users relation we just created in Pig into HBase under a users table, the users table that we just created, using this connector, the Phoenix HBase storage connector. And it needs a couple of parameters. One is the host name of the actual Phoenix instance that we're going to be talking to, and that's just running on localhost for us. But if you had Phoenix running somewhere else, you could specify a different host name or IP address there. And you also need to specify a batch size. So this means that it will wait for up to 5,000 individual entries and then commit them all together at once at the end. And obviously you want that to be no bigger than what you can actually fit in memory. A good default, I'm told, is 1,000, but we're using 5,000 here just because we do have enough memory to hold 5,000 users quite easily. All right, so now at this point, we have stored the users' data from MovieLens into HBase through Phoenix, okay? And we can then do some queries on it. So let's load it back. And to put a little bit of a twist on it, what we're going to do is only load back the user ID and occupation columns. Okay, so we're going to discard everything else. That's what this syntax means. So we're going to create a new occupations relation in Pig by loading from HBase the users table, but only the columns user ID and occupation. Okay, and we need to say using the actual class name of the Phoenix HBase loader connector class, so we can actually get Pig to talk to Phoenix. And again, we're going to specify the host name of where Phoenix is running. And in this case, it's just localhost. And now to make it even more interesting, let's do a little bit of a query on it. So at this point, we have a list of every user ID and their occupation sitting in the occupations relation, right? So let's group them up by occupation and find out how many people we have in each occupation. So to do that, in Pig syntax, we can say a new relation named grouped. For some reason, I stopped liking vowels here. Will be equal to group occupations by occupation. So we're going to take that occupations relationship and group together everyone that has the same occupation name. And then for each group in that relation, each occupation, we're going to generate a new relation that contains the occupation name and the count of how many times that occupation occurred. And then we will dump the results, okay? So stare at this a little bit more if you need to, but if you're good, let's go ahead and hit Q to get out of this view and go ahead and run it. So all we need to do is type pig phoenix.pig and let it go do its thing. This will take a few minutes. As you recall, Pig actually runs on top of MapReduce, right? So it's going to be kicking off a bunch of MapReduce jobs, and there's quite a bit of overhead to starting a MapReduce job. Once they get going, of course, things can run very quickly, especially if you're taking advantage of all the parallelization that MapReduce can do. But since we're using kind of a sledgehammer to drive in a thumbtack here, if you will. This is a very small data set, and in the real world, there's really not much point into doing something as complex as using Pig on top of MapReduce, on top of Phoenix, on top of HBase to store this data. But for massive data sets, this might be a perfectly reasonable thing for you to do. But let's just sit back and let this thing complete. So far, so good. Chugging away. And if you look closely at the different informational messages, you can get some insight into the actual mappers and reducers that are running here. So that's pretty cool stuff. You know, it's actually using Hadoop itself, MapReduce being a core part of Hadoop, and HBase running on top of HDFS, also a core part of Hadoop. So you can see how it all kind of fits together here. We're using HDFS, MapReduce, HBase, and then Phoenix on top of that, and Pig on top of that. And hey, it finished. So we got some results. Very cool. So you can see, for example, we had 28 artists in our data set and 196 students and 95 educators, which isn't too surprising given that the MovieLens data set came from a college. And looks like homemakers are kind of a rare person. There are just as many homemakers as there are doctors in this data set. Interesting. Cool. So it worked. That's kind of neat, isn't it? I mean, we've tied together some very complex and very powerful technologies here with just a few lines of code. So I think that's kind of awesome. And it just worked. You know, it wasn't even that hard, right? All right, let's clean up our mess. So let's go back to cd/user HTTP current Phoenix client bin. And we'll bring up our CLI again, see what's in there. Python SQL line.py. Exclamation point tables, you can see our users table is still in there. If you want to play around a little bit, we can say something like select star from users limit 10. Sure enough, there's our first 10 users from the Movie Lens dataset that we imported from Pig. It's still in there, so you could just import data from Pig, and that's a reasonable thing to do if you want to like get some intermediate MapReduce results maybe and get it into HBase very easily. This is one way to do it. So, at this point, you could have any sort of client on top of HBase vending this data at whatever scale you can imagine, right? So think about the power of what we just did. But just to clean up our mess, let's get rid of it. So drop table users, and then users should go away. Let's just make sure it's gone. Sure enough, it is. Then now we can quit out of Phoenix. And at this point, we can shut down HBase because we're done with it. And now we're back to where we started. So cool. There you have it, using Phoenix, and we've actually shown a couple of ways of using it, using the command line interface and also by using an integration with Pig. Remember though, the way you'll most commonly use Phoenix is through its JDBC client. So you can actually use a JDBC driver for Phoenix to make any application, or well, with some modifications most likely, talk to HBase as if it were a relational SQL database. So that's kind of the real power of Phoenix. If people have SQL clients or SQL analytics tools that they want to use on top of your HBase data, Phoenix is a way to connect them together. Oh, I have to hit the confirm stop button, don't I? So let's just assume that stops successfully. Trust me, it will. And we will move on to our next topic.